So first of all, it's a bad idea to try to find probabilities using the integral because the thing that you would have to integrate in the case of the normal is awful. And
Ugh.
actually, you don't even necessarily have the tools to be able to handle it. So that's why there's all this technology and table usage associated with the normal distribution. But what you're asking is, what in the world would you get if you just said not cumulative in Excel, right? That's basically
Yeah.
what you're asking. Well, it would just give you the value. I mean, yeah, it's kind of weird. It just gives you the value of the density at that point. Which
Okay. Yeah.
anything, because what's the probability of being equal to a point?
0.
Any continuous distribution. What's
It's 0.
zero? So like for instance, here I'll share this real quick. So was this the one that
Yeah.
this is part of what we were working on, right? So let me see. So probability, let's find like a simple one here. Probability that z is less than 1.55, right? That's given by this number right here, okay? Where z is the standard normal. But of course, I said that I wanted the cumulative distribution, the cumulative distribution here, yes?
Yeah.
Okay. But I am telling you, I could also have said, like you were saying, normal standard distribution. I could have put in 1.55 and said, no, I don't want the cumulative. And I would have gotten that, which is weird. What is that? Well, it turns out that's going to be the density evaluated at 1.55. It's the density evaluated at that thing. We'll give you that. And here, let me just kind of prove to you that that's the case. Do you remember what the density was? I kind of wrote it down during the lecture for the standard normal. It simplifies quite a bit for the standard normal. Equal
No.
to exponential raised to something. Exponential raised to what?
Uh,
Here, I'll write it right here.
oh, the z squared over 2, like negative z squared over.
Yeah, right. It was equal to e raised to the z squared over 2. Oops. And that had to be divided by the square root of 2 pi or something, right?
Yeah. Yeah.
That's what the density was. So watch, I'll kind of show you that that's what that's giving. Okay, so let's type in equals. You have to use x for the exponential function. So what's the thing that I'm squaring here? In this case, oh, by the way, this should be, I messed up. This should not be e to the z squared. It should be e to the negative z squared. Okay, over 2, all divided by the square root of 2 pi. So this is going to be equal to exponential. What am I squaring here?
1.55.
Yeah, so it's going to be negative 1.55 squared divided by 2, all divided by, okay, there's a square root function in here. Square root of 2, oh man, now I need pi. Is there a pi? Here it is. What? Pi?
I think maybe just close parentheses.
Huh. Will that do it? That doesn't seem to have given me the right thing. What in the world?
uh,
Pi? I need to know what that pi function is doing. Returns the value of pi. What? What's going on here? Huh. What's happening? Normal standard distribution. That is the density, isn't it? Is it 1 over the square root of 2 pi?
Yeah, it's 1 over the square root of 2 pi e. Could it be squaring the negative sign?
Oh, then maybe that
Uh,
is what it's maybe that is what it's doing. There we go.
oh yeah.
How weird is that? Why would it do that? Okay, so all that to say that what it will give you if you don't ask for the cumulative is literally just the density evaluated at that point, whatever that means, right?
Okay.
I mean, the density value is just the thing we integrate to find various probabilities. But yeah, so that's what that will give you. Does that make sense?
Yeah.
And of course, the density is slightly more complicated in the case of something that's not the standard normal, but yeah. Cool. Well, what else? Good question. Are you guys all at home?
Yeah.
Yeah.
You, Rachel?
Yes, I'm home.
Where's home for you?
North of Springfield.
Oh, okay. Wow. Okay, cool. What about you guys? Josh and Madeline?
I live in Cleveland, or the Cleveland area.
Madeline, don't you?
I moved from Vermont, so I live in Connecticut, and I'm moving again in like 3 weeks.
Oh man.
Oh, yeah, it was
Wow.
gonna be my family was gonna move out of the apartment without me, and then I was gonna come see the house after finals, but
Okay.
so that'll be a fun right before finals week.
Man. Sure. So do you feel, I mean, Connecticut, that wasn't the virus kind of like really bad there or something, or still
Yeah,
is?
we're not supposed to leave the state.
Oh wow. So how's that going to work for you guys when you move?
We're moving within the state, so that's good.
Oh,
We're
okay.
moving a half hour away just into a house. So,
Okay. Okay.
but yeah, so we're gonna just have to move by ourselves because we can't get anyone to help us. Like our church can't help because we can't expose anyone.
Wow. Okay.
So,
Man. Well, these are unusual times to be sure. I was actually reading about, I mean, I don't know if this is worthy of comparison at this point, but like I was looking at like the Spanish flu back in the early 1900s. That was like right at the end of World War II. Could you imagine? Like they were in a world war, and then this pandemic hits,
Mm.
and like a third of the world was infected by that thing, including like a lot of the soldiers. Um, so it was horrible, but this is not really on a scale like that quite yet, and the mortality rate was massive for that thing too. So, well, anything else? Anything?
I don't think so.
All right, cool. Well, maybe I'll have to incentivize people to show up in here, and maybe I have to just give really unclear, confusing lectures or something, and, and then they'll come and
Yeah,
ask.
you just explain things so perfectly. Nobody has any questions.
Oh, well, maybe that's it. Who knows? Yeah. All right. Well, cool. Somebody actually watched a lecture from my advanced probability class.
Oh, yeah, I remember that.
I think that was Aaron that did that. It must have been super confusing, but oh well. All right. All right. Well, hey, have a good weekend. Hopefully the weather is good wherever you are as it is here. It's really nice outside right now. So go enjoy that if you happen to have good weather. So yeah.
Thank you.
All right, thanks.
See you guys later.